Hey guys, this is Miss Adams. We're going to go back to part C on 16 because I realized I made a mistake here. So it actually is factorable because I did not use my calculator there. I said that 24 divided by 4 was 8 when in fact it is just 6. So I've got 2x minus 6. And if I factor by grouping, I can still factor out a 2 from each of those. So my first grouping was still x multiplied by x minus 3. My second grouping now is 2 multiplied by x minus 3 as well. These are the same, so my factored form is going to be negative 4 multiplied by x minus 3 multiplied by x plus 2. So my factored form again is negative 4 multiplied by x minus 3 multiplied by x plus 2. And now we're going to solve these by setting each factor equal to 0. But negative 4 cannot equal 0, so that doesn't work. I've got x minus 3 equals 0. I can add 3 to both sides to get that x equals a positive 3. And then I've got x plus 2 equals 0. I'm going to subtract 2 from each side and get that x equals negative 2. So those are my two solutions for part C. Let's go to the last page. So we got 5 more problems here. Again, we're giving you some different terms, but if you see roots, x-intercepts, solutions, guys, these are all finding our x-intercepts. So it says determine the roots of the function. I've got 4x squared minus 64. Now, you can look at this and be like, oh, well, Miss Adams, all of these both of these are perfect squares. But remember, the first thing we ever need to do is factor out a greatest common factor. Both of these are divisible by 4. So I'm going to factor out a 4. And I'm left with x squared minus 16. And this is all equal to 0. Now this makes it a little bit easier because I know x squared is x times x. And I know that negative 16 is 4 times 4. So my factored version here is going to be 4 multiplied by x plus 4 and x minus 4. So it tells me to determine the roots now. I can set each of those factors equal to 0. 4 cannot equal to 0. X plus 4 equals 0 and x minus 4 equals 0. For the first set, I can subtract 4. I get that one of my roots or solutions here is x equals negative 4. I can add 4 to the other. And I also get that x equals a positive 4. So I am totally fine with you leaving your answers like that for your roots. But you also could have put negative 4, 0 and 4, 0. If we ask you for the x-intercepts, though, like number 18, you need to give your answers as ordered pairs. So I have a trinomial here. Since a is 1, I can go ahead and say that this does not have a greatest common factor bigger than 1. So my a value is 1, b value is negative 4, and c is a positive 4. 1 times 4 is 4. So I need to find two numbers that multiply to a positive 4, but add to a negative 4. I know 1 and 4 and 2 times 2 are the factors of 4. So this looks a lot like that problem that we just did on page 2. I'm going to make each of my factors negative because a negative times a negative is a positive. So again, the only set that works here is negative 2 plus negative 2 because that equals a negative 4. So I'm going to break up my negative 4x into negative 2x plus negative 2x. Bring down the x squared and bring down the positive 4. I have 4 terms, so I can factor by grouping. If I am factoring the first group, I've got x squared minus 2x. Their GCF is x. And I've got x minus 2 left. In the second grouping, I'm going to factor out a negative 2. And I'm left with x minus 2 within my parentheses again. So therefore, my factored form is x minus 2 multiplied by x minus 2 is equal to 0. So that would be my factored form. But it asks us to find the x-intercepts. So in order to do that, I can solve both of these, but I should get the same solution because they are the same. I can add a 2 to both of these, and I get the overall solution that x equals 2. So, therefore, my one x-intercept for this quadratic is 2, 0. It says to do the same thing for 19 and 20. It says find the x-intercepts of the following, but you're in luck because it's already in factored form. I'm going to set the first grouping 2x minus 1 equal to 0. Add 1 to both sides. We get 2x equals a positive 1. Then I can divide by 2. I get x equals negative 1/2. Not negative, I apologize, just positive 1/2 here. Or I can write that as 1/2, 0, because it is an x-intercept. Leave it as fraction. Second grouping is x minus 2 equals 3, or equals 0. And I'm going to add 2 to both sides. And I get x equals a positive 2. And my x-intercept there would be 2, 0. For number 20, I'm doing the same thing. I'm finding the x-intercepts. So I have 2x minus 6 equals 0. I'm going to add 6 to both sides. I get 2x equals a positive 6. I can then divide both sides by 2. And I get x equals 3. And I can write that as 3, 0 for my x-intercept. I've got x minus 3 equals 0. I'm going to add 3 to both sides. And I get x equals positive 3, or 3, 0 again. Since they are the same, you would only need to write one of them. And it would do the same thing as the problem 18. Remember, we would, if I'm looking at that on a coordinate plane, I know that I would only have one x-intercept at 3. So my parabola would look something like this, where our vertex and our x-intercept would be the same coordinate pair. Let's go to problem 21, and this is the last one for our Unit 7 test review. And this kind of contains a little bit of everything. It says factor completely and solve for the solutions. First order of business is I've got to look for a greatest common factor. My lowest coefficient is 3, so I'm going to divide each term by 3, because 15 is divisible by 3 and 18 is divisible by 3. So my new function here is going to be 3 multiplied by x squared minus 5x minus 6 is equal to 0. My new a value is 1. My new b value is negative 5. And my new c value is negative 6. I'm going to say that 1 times negative 6 is negative 6. So I need to find two numbers that multiply to negative 6, add to negative 5. We got 1 times 6 and 2 times 3. I want them to multiply to be negative and add to be negative, so I'm going to make my larger factors negative. And the only factor pair that works here is 1 plus negative 6 to equal negative 5. So I'm going to break that middle term of negative 5x into 1x minus 6x and bring down the negative 6 and the x squared. I now can factor by grouping. The greatest common factor from the first group is x, and I'm left with x plus 1. The greatest common factor in the second grouping is a negative 6. Since they're both negative, go ahead and take that negative out. And I'm also left with x plus 1. These are the same, so my factored version is going to be 3 multiplied by x plus 1 multiplied by x minus 6 is equal to 0. So that is our factored version of this. But then it says to solve, so I'm going to go to the other side here and solve this. 3 can never equal 0, so I know that can't be a solution. So I've got x plus 1 equals 0, and I have x minus 6 equals 0. I can subtract 1 from both sides, and I get that x equals a negative 1, or I can put that as negative 1, 0. I can add a 6 to both sides, and I get x equals a positive 6. Or I could write that as 6 comma 0. And guys, that's the end of our Unit 7 test review. Please reach out to us if you have any questions. Have a great day.